start the recording. What is that? Tired? Y equals, our first root is going to be at -2. So we have x equals -2 multiplicity of 4. So if I turn that into a factor, I would just add it to the other side. And then that multiplicity of 4 is going to become my degree. The other one we have is x equals 1 multiplicity of 2. And so if I turn that into a factor, it would be x minus 1. And now my multiplicity is my degree. We okay with those? Yes. Okay. Based upon this, can you tell me the degree of this polynomial? 6. Does the graph make sense for 6? Do you think the a value is going to be positive or negative? Why? So we kind of got an idea of what's going on with polynomials. They're not too hard, are they? Much better than all that counting pattern stuff, right? You just rush it, go with it. Okay, so we do also have a point right here at 0, 16. So we can use that to find our a value. So if I plug in 16 equals a, 0 plus 2 to the 4th, 0 minus 1 squared, I get 16 equals something a.
Do they ever word it weird, or will it always just be like right there at the bottom, like the multiplicity of 4?
They could write it like this. They could have told you it was 6 degrees. The degree of this function is 6. So based upon it being 6, you know the 1 is 2. So something you might just have to think through. Okay, so what do we get for this number in front of 16? Holy cow. 2 to the 4th is 16. And then -1 squared is, so a equals 1. Okay. So then we have y equals, well, I don't even need to worry about it. And we do not have to FOIL these all out. It didn't say to put it in general form. That would be dreadfully bad. By looking at this, can't you already tell that the a value is going to be 1? Because what's 2 to the 4th? What's -1 squared? So I already have my y-intercept, right? Do you know what the leading term for this one would be?
1. Oh, no, I don't.
X to the 6th. Oh, you have to just take your first term, x to the what? To the 4th, x squared, so x to the 6th. Are there any other numbers involved? Okay. Because sometimes they're going to ask you things like that, and you don't have to literally FOIL it all out to get the answer. Okay, so now we got the same type of scenario, but this time we've got some odd roots going on. But the overall function, what's the degree of our function?
8.
Yeah, so we got a 0, -2. We got x equals 1 multiplicity of 3. We got a x equals -1 multiplicity of 5. So you can see the difference between the cube and the 5th, or the multiplicity of 5. And then, of course, this multiplicity of 3, well, what does 1 look like instead? It just goes straight through like a line, right? But this one's got a little flat. Almost like about as much as that little bounce for the quadratic. So here we've got y equals a. I'm going to have x plus 1. And it's going to be to the 5th power. And then I got x minus 1. That's going to be the 3rd power. So then we could plug in our -2 equals a 1, 0 plus 1, and 0 minus 1. And what does a end up equaling? It totally does. So y equals 2, x plus 1 to the 5th, x minus 1 cubed. Could you tell me what the first term is? The leading term? 2x to the 8th. Can you tell me what the y-intercept is without this? Can you see how it'd be 1 to the 5th times -1 times 2? So it's -2. Those would be your last terms. So what would be the leading coefficient? 2. Good. I think you got it all. Okay.